Welcome to Learn Chemistry Together. This video is about development of lithium-ion battery. The 2019 Nobel Prize in Chemistry was awarded to John B. Goodenough, M. Stanley Whittingham, and Akira Yoshino for developing the lithium-ion battery. This rechargeable technology enabled wireless electronics and paves the way for a fossil fuel-free world through renewable energy storage and electric vehicles. The story of the lithium-ion battery. Lithium, the lightest solid element discovered in 1817, is reactive because its single outer electron easily forms positively charged ions. In the 1970s, Stanley Whittingham used this reactivity to build the first functional lithium battery. In 1980, John Goodenough doubled its potential, creating a much more powerful battery. In 1985, Akira Yoshino made the technology practically viable and safe by eliminating unstable pure lithium in favor of lithium ions. This evolution of the lithium-ion battery enabled the creation of mobile phones, laptops, electric vehicles, and renewable energy storage from solar and wind power. We will now step 50 years back in time to the beginning of the lithium-ion battery's highly charged story. Rising smog and fears of a finite oil supply in the mid-20th century prompted companies like Exxon to invest in alternative energy research. Stanley Whittingham, recruited by Exxon in 1972, studied intercalation, how charged ions fit into atomic spaces within solid materials. While investigating tandem disulfide, he discovered that adding ions yielded surprisingly high energy density and voltage. Recognizing potential for electric vehicle batteries, he replaced heavy tantalum with much lighter titanium to build a better power source. In the Stanley Whittingham's lithium battery, lithium was chosen for the negative electrode, the anode, because it readily gives up electrons to drive the current. Impressed by its great potential, Exxon management quickly decided to develop Whittingham's discovery into a commercial product. Unlike traditional batteries with electrodes that broke down during chemical reactions, Whittingham's design stored lithium ions within the spaces of the titanium disulfide cathode, flowing back and forth during use and charging by the intercalation mechanism. Whittingham's early rechargeable lithium battery faced a major safety hazard. During charging, lithium whiskers grew from the anode, causing short circuits and explosions. Despite modifying the electrode and electrolyte for small-scale production, falling oil prices in the early 1980s forced Exxon to cut back and discontinue development. The technology was licensed to external companies, and John Goodenough took over the research. Motivated by the 1970s oil crisis to research alternative energy, physicist John Goodenough left MIT's Lincoln Laboratory after many years to become professor of inorganic chemistry at Oxford University. This transition allowed him to shift his focus from early computing components to critical energy research. John Goodenough reasoned that using a metal oxide instead of metal sulfide could significantly increase a battery's potential. Through a systematic search, his team discovered that a lithium-cobalt oxide cathode produced an impressive 4 volts, nearly doubling Whittingham's original battery power. Crucially, Goodenough realized that batteries could be charged after manufacture rather than needing to be built in a charged state. Published in 1980, this lightweight and high-capacity cathode material marked a decisive step toward the wireless revolution. While Western interest in alternative energy waned with falling oil prices, Japanese electronics companies like Asahi Kasei Corporation, spearheaded by Akira Yoshino, urgently sought lightweight, rechargeable batteries to power innovative new devices like video cameras and computers. Akira Yoshino created the first commercially viable lithium-ion battery by combining Goodenough's lithium-cobalt oxide cathode with petroleum coke anode that safely intercalated lithium ions. Because the battery operates by ions flowing between electrodes without degrading chemical reactions, it achieved a long lifespan and exceptional stability. Eliminating pure lithium resolved the severe explosion risks of earlier designs, as proved when Yoshino's prototype survived impact tests without incident. Passing this crucial safety test in 1986 marked the true birth of the modern lithium-ion battery, as Akira Yoshino says that this was the moment when a lithium-ion battery was born. Commercialized in 1991, the lithium-ion battery revolutionized electronics and remains unmatched in capacity and voltage despite ongoing research. Through continuous improvements by laureates John Goodenough, Stanley Whittingham, and Akira Yoshino, these batteries have enabled portable technology and paved the way for a cleaner, fossil fuel-free society. Thank you for watching. Click subscribe or follow to support this channel.